the area can also be calculated in a different manner. So we are going to look at a different approach to calculate the area. So for this case, the boundary of the area can be considered to be bounded from the left by this curve, and it is bounded from the right by this curve. So it is actually possible to calculate the area by partitioning the area along the y direction instead of partitioning along the x direction. So let us look at the more general situations. So if you have, say, a area bounded by two curves, one on the left and the other on the right, between some values of, say, y1 and y2, then the area bounded between these two curves can be calculated using the following manner. In this case, the left-handed function can be considered to be a function of written in the form of x equals to g of y and x equals to f of y. So this is the notation that is used in the slide. The left-handed boundary is assigned as g of y, and the right-handed boundary is assigned as a function of f of y. So this curve is actually described as a function of y instead of as a function of x. Most of the time in our course, we usually write the function in terms of like this, where x is an independent variable and y is the dependent variable. However, in order to perform a calculations of the area that's bounded by a curve on the left and a curve on the right, then we have to consider a alternative approach of describing the function. So instead of expressing this curve as in the form of y equals to g of x, we have to express this curve as in the form of x equals to g of y. So it is always possible to do that. Just to give you an example. Say you have a curve like this. So this is a curve that is expressed in the form of y equals to f of x. So in this case, if you know what is x, then you know what is y. Now, however, if you were to revert this a little bit, then you make x as your title, then you make y as equals to, you make x as equals to y plus 2. So if you do the simple change in the arrangements of this formula, you can express x as equals to y. So in this case, you can consider the x to be a function of y, and this is to be expressed as y plus 2. So this function of y equals to x minus 2 that describe this curve can equally be expressed in the form where you make x as a title instead of making y as a title. So if you make x as a title, then you can treat the values of x to be dependent on the values of y. In other words, the values of x is determined from the values of y. So say for example, you choose any point of say y here, say you call it y1. If you know what is a y1, then the values of here, I call this x1. Then the values of x1 can be calculated from this very simple formula, that is the values of x when y is equals to y1 is simply equals to x1, where x1 is just y1 plus 2. So in this case, the function x equals to y plus 2 allows you to evaluate the coordinate of x if you know what is the coordinate of y. Likewise, for the same values of y1, at this point, the values that correspond to this x coordinate on the curve of y equals to square root of x, let me call this as x1 prime. So x1 prime can be calculated if you know what is y1 and the formula for this curve expressed as a function of y. So let me try to show you how you can convert this curve from the form of y equal to square root of x into a form that makes x as the title and y as the independent variable. So this could be easily done by simply squaring both sides. If you square both sides, then you get x equals to y squared. So this is just a very simple steps where you make x as the title of a formula. So when you convert this expression into this form, then what you can say is that this is the function that is dependent on y and is equals to y squared. So here you have a function in the form of x equals to y squared. So if you know what is the values of y1 at this point, then x1 prime is simply given by this formula. That is, x1 prime is just the values of the function when y is equals to y1. So that allows you to calculate the values of x1 prime in terms of y1 to be x1 prime as y1 squared. So here we have just shown you the same curve expressed in this ordinary form can also be expressed in the form where you make x as a function of y. So it is always possible to have a curve to be described in the form where you make y as the argument and you make x as the title. Okay, so anyway, you just accept that a curve can be also expressed in terms of g of y and f of y, where g of y is describing the left-handed boundary of an area and f of y is describing the boundary of this. So in this sense, then you can make a partition. With this, then you can make a partitions of the area into n partition, where each of the partition has a width of delta y. So let's say you choose a number. Let's say you choose a number of say ck that is sitting between the y within this column. So you have the values of ck at this point here. Then the value of x for y equals to ck can then be easily calculated to be the values of f at c of k, and this is then the values of g evaluated at c of k. With this knowledge, then you can write down the area of this column, which is lying horizontally. So I'll call the area delta AI to be just equals to the width of the column delta y multiply with the length of this column, and the length of the column is always taken to be the right-handed boundary minus the left-handed boundary, because f is always larger than the values of g for the same values of y. So the right-handed boundary is described by f evaluated at ck minus the values of the function g evaluated at ck, where ck is just a number that is lying along the y-axis and is sitting inside this particular column of k in the partition. So then the area of the function can then be taken as the Riemann sum for this partition, that is when p goes to 0, the sum of delta ai for I summing from 1 to n. Then when you carry out a little bit of calculations, you will arrive at this expression, which will then further be shown to reduce to the definite integration form of f of y minus g of y, integrating y from the lower limit of y1 to y2. Here, y1 is the lower limit of the boundary, and y2 is the upper limit of the boundary. Y1 is the lower limit of the boundary. To conclude, given an area bounded by two curves on the left and on the right, in which the left hand curve is given by the form of x equals to g of y, and the right hand curve is expressed in the form of x equals to f of y, then the area that is enclosed between the lower limit of y1 and y2 is then just simply given by the difference of the right-handed boundary and the left-handed boundary, integrating dy from y1 to y2. We can then apply this method to the function we want to integrate. Here, the function we want to integrate is in this form. So let us try to see how we do that. Let me rewrite the curve again. So this curve is given as square root of x, then this curve is given as y equals to x minus 2. And it is obvious that the boundary is given by this formula, and the left hand curve is given by this formula. Therefore, I'm going to obtain the function of g of y, which describes the left-handed boundary, and I'm going to try to obtain the expression for the curve that describes the right boundary in terms of the function of y. So let me try to see how I obtain the g of y first. So g of y can be obtained from this expression, which is quite easily done. So how I would do is how I'm going to do this is very simply to make x as the title for this function. So if I make some rearrangement, this will give me x as equals to y squared. So you can consider this to be just the gy function. So from here, then I am now able to write down the expression for g of y, which is just y squared. Now let us try to obtain the expression for f of y. F of y can be easily obtained from this expression. The original expression is y equals to x squared. So you can simply make x as the title of the function. So you make x as equals to y plus 2. So this function, y equals to x minus 2, is now expressed into this form, x equals to y plus 2. And then what you can say here is the right hand side function is just your f of y. So now I claim that the right handed function fy is just y plus 2. So now I have already obtained my function of g of y, which is just y squared, and also the f of y is just y plus 2. So now I'm ready to calculate the area of the bounded region. So I need to know what is the integration range from y1 up to this point, which is y2. Here y2 is the values of the function when x is equals to b equals to 4. So this value has been calculated to be just 2. So I'm going to integrate for the area A, which is just the right-handed function of y minus the left-handed function of g, integrated with respect to y from y1 equals to 0 to y2 equals to 2. And here I would write down the fy, which is y plus 2 minus g of y, which is y squared. And I'm going to integrate this from 0 to 2. This will give me y squared over 2 plus 2y minus y cubed over 3. And it's going to be evaluated between 0 and 2. So you will carry out this calculation and you get 4 plus 4 minus 1/3 of 8, where I substitute y equals to 2 into the expressions, and then when I substitute y equals to 0 into the expression, I got 0. So that could then be give me some number which I don't bother to write down. You can calculate this for yourself. Here the result for the calculations is now clear. The integrations of these functions, the difference of the function of f and g, then you will arrive at the correct answer that is just given by the sum of this very simple expression. So that finish up the integrations of a function bounded in this manner from the left and from the right by two curves given in the form of g of y and f of y. As a conclusion to this video, we have learned how to perform integration for the area bounded by two functions. So you could have these situations bounded between a and b along the x-axis, where the area is bounded by a function y equals to f, which is larger than the other curve, which is described by g of x. Then this area is then simply given by the integrations of the upper function minus the lower function, integrating the functions from a to b. If you have another situation where the area is bounded by two curves, one on the left and one on the right, where the left function is given in terms of g of y and the right-handed boundary of the area is given in terms of x equals to f of y, and y is bounded from y1 to y2, then the area A is then simply equals to the integrations of the right-handed function fy minus g of y. Here you integrate y from y1